In our last video here, we're just going to do a little more practice working with this continuous compound interest formula and solving for different parts of it. So in example 4, we have an investor that paid $99,000 cash for a house. 3 years later, the house was sold for $150,000. If the interest is compounded continuously, what annual nominal rate did that original $99,000 investment earn? So again, I'm thinking about my continuous compound interest formula, which says A equals P times E raised to the RT. If I think about what I know for this particular problem, I started by investing $99,000 into this house. So that's my initial investment. P is 99,000. Let's see, 3 years later, so I had my investment for 3 years, so that's my T is equal to 3. It says the house ended up selling for 150,000. So that was my end balance. So that means that my A is 150,000. The question here is asking, it says, what annual nominal interest rate did this investment earn? So I'm trying to solve for my interest rate R, which is the only piece I'm missing here. So, all right, we can take everything that we know and plug it into our our continuous compound interest formula, which says A, so that's 150,000, equals P, 99,000. E to the, let's see, R, I don't know what R is, so we'll leave that as R, times T, that's going to be 3. So again, I need this exponential part by itself. I need to solve for that part first, which means I need to divide both sides by 99,000. So here on the right-hand side, I get e to the 3r power, which is exactly what I wanted. On the left-hand side, be careful. Again, I don't want to do any rounding because I'm going to be working with this number still. I have 2 more steps to do with this number. And if I round right here, I'm going to make a mistake. And as I work with that mistake, it's going to snowball. So I really don't want to round any decimals. So I would like to leave this as a fraction. If you want to cancel some of the zeros, we've got 3 zeros in our numerator and 3 zeros on our denominator. We can do that and say, okay, let's work with 150 divided by 99. So this is what I'm going to be working with for my left-hand side. And on the right-hand side, I've got e to the 3r power, which is exactly what I wanted. Now I can take the natural log of each side. So if I take the natural log of the left-hand side, I'm just got, well, natural log of 150 over 99. If I take the natural log of this right-hand side here, well, remember natural log and e, those are sort of inverses. They cancel each other out, so I'll just be left with 3r. My last step then to finish up solving for r, well, if I divide both sides by 3, I end up with, r is equal to natural log of 150 divided by 99, all of that divided by 3. Be careful as you're typing this into your graphing calculator. Again, just be aware of your parentheses where you need to start and stop them. I should have natural log of 150 divided by 99. Take that, divide it by 3. I ended up with, let's see, 0.13, can't really see that, can we? 0.1385. Here I rounded to 4 decimal places because then if I convert this to a percentage, which would be 13.85%, now I've got those 2 decimal places. So just depending on what format the question is asking for your answer in, here would be the decimal form, here would be the percentage form. Just be aware if you want to find your percentage you're going to have to round to 4 decimal places instead of 2 when you find the decimal. Cool, there we go. Let's take a look at one last example. I think that these questions are really neat. So this says, how long will it take your investment to double if invested at 5% compounded continuously? This looks like it's a relatively short question because, to be honest, we don't have a lot of information in our problem here. Okay, we've got this 5% compounded continuously, so I know that's my interest rate. So I know that, okay, R, that's equal to 5% or 0.05. Beyond that, I'm looking for, okay, it says how long, so I know I'm trying to solve for t, so t is going to be my variable. That's what I'm trying to solve for here. But if I think about the other parts of my continuous compound interest formula, I still need to know what is p and what is a. I don't really know what those are. It didn't tell me what those were. What's really cool for this problem is you can actually choose whatever you want for p. So let's just leave p. I'm going to leave p actually as just an arbitrary value, p. I'm just going to leave p as, okay, it's by itself. But that means that a, if I want my investment to double, well, double means I would multiply that by 2. So that means I want to end up with double whatever I started. Well, here's what I started with. It's p. So that means double of that would be, well, 2 times p. And I can actually use this and plug it into that continuous compound interest formula. So let's try it here. Let's see, I should have a, so we're saying a is going to be 2 times p equals p, well, we're just going to work with p here, times e raised to the r, that's 0.05, times t, that's my variable, so we're going to be solving for t here. So if I think about wanting to solve this equation now, well, if I want to solve that equation, again, I need this exponential part by itself first, which means I got to divide both sides by p. So when I divide both sides by p, I end up with 2 is equal to e to the 0.05 t power. Hopefully we kind of know what to do from here. I'm going to take the natural logarithm of both sides to to get rid of that exponential. So if I take natural log of the left-hand side, I'll have natural log of 2. And the right-hand side, natural log and e, those will cancel. I'll be left with 0.05t. So that means that t must be natural log of 2 divided by 0.05. If I want an approximate answer, let's see, natural log of 2 divided by 0.05, I ended up with 13.86 years. So here is my solution for t. It's 13.86 years. What's kind of cool about this problem is when I said at the beginning, I said, well, we don't really know what a is and we don't really know what p is. And I actually said you can choose whatever you want for p. It doesn't actually matter. So if you wanted to go back to that first example and call p 10,000, well, double that. That would just mean my a has to be 20,000. And actually, if I plugged 10,000 and 20,000 in for a, I would end up with the exact same value for t as my solution. I'd encourage you to try it. It's pretty cool. But you can pick whatever you want. So you could pick p equal to, $10, and a would be $20. Or my personal favorite, p is $1, and how long will it take that $1 to grow into $2? What's neat here about this is it doesn't matter how much you start with. What you end with is always going to be double that, and it doesn't matter whether you're going from $1 to $2 or 10,000 to 20,000. Regardless, it's still going to take the same amount of time, 13.86 years. So I'd encourage you to try that out. Try picking a different starting value for P and then solve that equation for T and see if you get the exact same solution.